Good afternoon, everybody. I am Charan Kumar, Assistant Professor in the Department of ECE. Today, we'll see the first experiment regarding the in the EDC lab PN junction diode. PN junction diode. Forward and reverse bias characteristics of PN junction diode. Characteristics of PN junction diode. First of all, PN junction diode is a fundamental semiconductor device formed by P-type and N-type materials. P-type and N-type materials. See in the diagram, we'll see P-type materials and N-type materials. Here, the P-type materials, the majority charge carriers are holes and minority charge carriers are electrons. In the N-type, majority charge carriers are electrons and minority charge carriers are holes. In the middle of the junction, this is called depletion junction. The depletion junction is nothing but the both combination of P-type and N-type to form the further movement of the PN junction diode. Next, forward bias and the reverse bias. Forward bias consists of first one, diode is connected to the voltmeter and ammeter, and we are connecting to the power supply, ground, next we are connecting to the RL 1 kilo ohm diode IN 407. IN 407 is nothing but the series. Here the power supply you are applying RPS is nothing but 0 to 15 volts, and ground it is mandatory the voltmeter 0 to 20 volts and 0 to 200 milliamperes. This is the forward bias. The P here in the diagram, the positive terminal is connected to the P-type and negative terminal is connected to the N-type. Here the depletion region, in the forward bias, the depletion region shrinks. Shrinks is nothing but it takes a small amount. Shrinks nothing but it takes a small amount. In the reverse bias, it is very easy. Only the diode is reversed. The diode is in reverse bias condition. Same. the power supply, the ground, ammeter, voltmeter, RL, 1 kilo ohm, 2 volts, 0 to 200 milliamperes. Same, the diode is in reverse bias. In the p type, it is connected negative terminal of the diode, and in the n type, it is connected positive terminal of the diode. Here it is the reverse condition. Next, we are seeing the simulation model in Ni multisim. Ni multisim. Ni indicates national instrument. And multisim indicates multiple simulation. The multiple simulation, it is used to design the simulation of electronic design for industry purpose, education purpose, industry, education, etc. Next, what is Ni multisim 3.0? This is the version. Next, you can see in the system Ni multisim software. Open the Ni multisim software. Ni multisim 3.0. version. Here file, edit, view, place, everything is available. Next, here the place source, the sources what we want, the sources, resistors, capacitors, transistors, and every source is available. Every source is available, and power sources, signal voltage sources, signal current source, controlled voltage source, controlled current source, controlled function blocks, digital sources. Next, we'll go for, in the sources we can search basics. Basic is basic virtual and switches, capacitors, resistors, inductors, capacitors, everything is available. Next, this is the place diodes. What type of the diodes do you want? You can search here. Search, you can, in the function you can search, component you can search, you can automatically, it will get the, it will shows the output of the diode. Next, BJT, NPN, transistors, whatever the diodes do you want, transistors, you can search and you can get. First of all, in the experiment, in the forward bias, we are going for the power sources. We are selecting the DC power, not the AC power. AC power is different, DC power is different. DC power source, and we are selecting in the next to the DC power, the ground is available. It will goes to the ground, and okay. Next, we want diode, go for the sources, click on the diodes, and we need to search IN4007G. Can click on OK, it will automatically, it will shows okay. Next, here, next we need to go for the resistor. Click on the resistor, we need to select 1 kilo ohm. Okay, click on OK and release. Just you need to select and just drag the component, it will automatically drop to the screen. Just you need to arrange in your order in the circuit order the resistor. Just right click on the resistor, just rotate 90 degrees clockwise. Just at the end of the at the end of the diode positive terminal, it will highlight the plus symbol. Just you can take the mouse and you can drag the line. You can connect to the positive terminal of the power supply. Next, and the negative terminal, it will goes to the negative terminal of the resistor, and the negative terminal is connected to the positive terminal of the resistor. Next, the diode, it will connected to the the ground, it is connected to the ground. Next, go for the simulate. We need to check the simulation. Go for the analysis, DC sweep. In the here the DC sweep analysis, parameters, output, and analysis option summary. We need to check the voltage. First starting value we are giving 0. Here you need to change the value to the 15 volts. Just double click on that and change the value to the 15. And you can go for the simulate, go for the analysis. You can check the DC sweep, and start value 0 and stop value you are giving 15, and the increment value, the wave it will start 0.5. Output, what do you want the output voltage? You can add the source, you can add to the all variables. Just click on the simulate. Automatically the wave will forward bias wave, it will get, it is the black background is there. You can click on the black background, just automatically it will change to the white background. Here at the place of the minus 2.5, just double click on that. Minimum you need to keep the value of 0, apply, it will starts at 0. This is the forward bias characteristics. Next we'll go for the reverse bias characteristics. In the reverse bias characteristics, only the diode need to reverse. The diode needs to reverse. Just delete the wires which is connected for the, just connect reverse. P type is connected to the negative terminal and N type is connected to the positive terminal of the diode. Go for the simulate, analysis, DC sweep. No need to change any value, start value, stop value, and the increment. Just go for the output. Just remove the voltage. We want the current source. Now just add it and just simulate. You can get the reverse bias. You can get the reverse bias wave. Automatically we can get the wave, just current. Okay. Is there any doubt? Maximum, general, left axis, no need to change anything here. Just you can check it the wave, that's it. Here why we are removing voltage and the amplifiers means no need to add that voltage and amplifiers. You can directly get the wave easily. Thank you.